Welcome to functional programming. Is this thing on? I've been trying the restream. The restream. Oh, it's working. All right. Oh, I have to pop up the chat just in case someone drops by. Yeah, okay. Right. Let's exit the shell, cd code. Let's go to make a lambda. I have a lambda here. Oh, goes TI. All right, bitrate. Everything's working. So it's been a while since well, the holidays and all the stuff, since I did studying functional programming. So let's open up the book. I think I will have to actually refresh all that. So it's this. Yeah, I don't need this. Can't. Not. So I've been having very, let's repeat the functions that we have. So I'll just raise the font like this. So let's go to Nix REPL. So I've been using, although it all began with SML and then Haskell REPL, I kind of like the Nix REPL because it's very minimal. So it's just like this, right? So instead of the dot, we have the colon, right? And well, this was our basic identity function, right? That basically just gives you back whatever you give it to, and it could be in any type. So I think actually the correct term also would be that the identity function is a polymorphic function because it can take all the types there are. So it can take hello there, right? So, and we call that identity. And identity 2, right? And then what we did the identity. And what was then? It's because the way the book actually progresses, it's not like usually the lambda, someone would introduce already occurring in like x, y, x plus y, right? And then you would do like x, y, x plus y, 1 and 2. And that's like 1 plus 2 is 3. But this already comes up, this is still not actually covered in the book. It comes a bit later, where we have to define even the plus. So this is kind of, we presume here, for granted, in some sense, the operation of addition. Yeah. So this is working. So what was after the identity? Oh, after the identity, there was the self-apply function. But it didn't work in the self-apply. Self-apply was something that applies something to itself. It was like the S and then SS. So the head of the function is the S, and then the argument is that argument itself applied to itself. Right, so the self-apply 2, we're going to attempt to call something which is not a function but an integer. Oh, it is expected that it's a function. Right, I cannot just, because SS, this is the way function application works. The first thing is the function and you apply it to something. So we cannot do, I guess you could do like this, SS, and we're going to pass it in the identity function, XX, and then we're going to pass it in number 2, and we're going to get a 2. Yeah, but it's funny that the self-apply definition did not work in the Haskell. I have a message. Oh. Ne znam. Mama, Tito, just. Da. So then we did the apply function. The apply function. So the apply function was also very interesting. The apply function was, well, you have an you have an argument. It's always, so first you write an argument, a, and then let's say you have the function f, and then f is applied to a. So this is the application function. And it's kind of, yeah, because I haven't been doing this for like a couple of weeks, and now it's kind of triplet summary apply. Look at this, function argument, function argument. So we do not have to, yeah. Okay, so apply is function argument fa. The prime time, I will not write Rust again. That's funny. I'm subscribed to the Parmesan, the Parmesan, the Prime Gene. I always forget. And his latest video is titled "I will not write Rust again." All right, funny. Apply FA, and yeah, you see, after a couple of weeks, I'm like slow, but okay, apply FA. But okay, we don't have a plus now, but apply. I guess you could do it like apply plus, right, to 2 and 2. Will this work? Cannot coerce a function to a string. Yeah, I thought this can be like apply plus 2 and 2 like this. No. Apply plus. Oh my god, I sound like slow. Apply function argument. Apply arc. This is such a, I'm so slow. Yeah, there are all these substitution exercises that are really good to do, and they are kind of hard to do in the REPL because the REPL evaluates everything, and you don't see the steps. There are some programs, and I guess that would be interesting to write a stepper kind of a thing that would step through each evaluation. Function argument. Well, maybe I'll just continue for where I stopped. Name clashes, Lambda conversion. free variables. Yeah, I remember this. Well, I don't think I have to go to do everything again. That'd be well. I'll maybe I'll start again with the conditional. We did the select first though. Select first was, well, there is a function a. Let's see if this works. A, B, and then, right, F, A, B, F, A, B. So select first, takes a function, applies it to two things, and thus makes a pair. Mm. Sorry. Select first FAB, FAB, right? And then select first. Will this work? Select first of hello next. Select first. Undefined select. It doesn't pick it. Select first. Yeah, it doesn't. It selects it, but we'd only get a lambda. Wow, I feel so slow. Like at the beginning, you see when you make constantly streams about this and you learn, it's even if you don't know, you have this momentum. I've kind of lost the momentum, but it's important to be consistent. Select first hello. Wait, would it be different if I do select first F A that takes an A, takes one thing, takes second thing, then a function that does FAB? What do you mean unexpected? Oh, select first is what? It's not the same. AB, FAB. Sorry, I'm like, I'm kind of. Okay, wait a second. Select first hello.next. This is horrible stream. I'll probably lose everything. I'm joking. Select first hello next. So this is very slow, and I'm intentionally recording this. Select first hello next. Yeah, it won't select actually. Select first is a, well, it's a function that does three things. Three things. Takes one thing, takes second thing, takes a function that adds these two things. But we cannot just select first. Make pair. Wait, we select FAB. No, this is completely wrong. I've just realized. Select first is a function that takes one thing, takes second thing, and gives the first thing. I'm not even thinking. I'm sorry. So now we should select first hello world. Let's do hello world. We get hello. And so that means select second is takes one thing, takes the second thing, but gives you back the second thing. So select second hello world should give us back the world. But then we did the make pair function. So what's the make pair function? So it's nice, like make pair function is something that it's like the select first and the select second, but it's like it takes the two things and it makes a pair out of them. So make pair is takes the first thing, takes the second thing, then takes a function that makes a pair out of these two things. I think it's like this. So then make pair. So look, if I do this, hello next, and nothing will happen. But if I pass this to select first, make pair, hello next, and then select first, I get a hello. So the make pair takes the first, so the make pair makes a pair out of these two things. And then select first, well, because we have a lambda here, because the head is here, and then the select first, well, this is the part where you need to, where we practice the evaluation steps. I guess I should cover this all again. HX notes MD. So if we have, so we said make pair hello, well, we could do A and B. Make pair A and B select first. So let's see what's going on. Make pair. Okay, one of the things, it's do you substitute the function definition for the function body itself? No, do you substitute the function name for the function definition? So the function name is make pair, and the function definition is A, B, F, F, A, B, right? Maybe I should change this so that it makes more sense. Let's do hello world. Something simple. Maybe 1 and 2, because we have already A and B. 1 and 2. Maybe like first and second. First, second. First, second, and then we have a select first. Select first is A, B, A. Maybe we should do so that we don't have, so it's easier to understand, X, Y, X. So first and second, A, B, yeah. So what's going on? Yeah, so the way the function, so we first applied this. So now yeah, okay, this is how the function application works. So the make pair, well, let's do first, FST. But we are not supposed to, I think this is not the correct thing to do. I think this has to do with eager evaluation and lazy evaluation. And in lazy evaluation, we wouldn't actually substitute this name for the definition, right? So to make this more clear, I'm gonna keep it like this. Now the first is gonna go to the head of A. That's the first argument, right? So then we're gonna substitute, so we remove the head, right? We're gonna be left with B, F, FAB. And well, instead of the A, we said we're gonna have the FST, right? So now we don't have FST anymore. I guess you could do it like this. And SND select first. Right, so now we have B, lambda F, FST B. So we substituted within the body of the function. We remove the head, and in the body we have the FST. So now we substitute the second for the second here, right? So instead of the B, we remove the head of the B. We're going to be left with the F function, F, FST, SND, right? And now we have select first. lambda. So what do you do now? But you see what's going to happen now? That's actually very pretty. We have this lambda head here. Lambda FF and the FST SND that are, could be whatever we want it to be. Now select first. It's going to substitute this, right? Now it's really very simple. Now select, well, it's very simple. It's like in functional programming or like more like math. So it's like, oh, now it's very simple. We just do this and we just do that. So select first, we remove the head now of the F and we substitute within the body, right? We put select first. And we have FST, SND. And now select first is going to pick the first. But if we, and now we can substitute the function definition for the function name, or maybe the substitute the function name for the function definition. Not sure which way around. So select first is what? A, B, A, FST, S, and D. Now we have the FST is going to substitute the A. And we're going to be left with the B, lambda B, and inside FST. No. Substitute A, lambda B, FST. Yeah. S and D. And now S and D is going to substitute for the lambda B. But here's the kicker. There is no B in the body. There is no argument B in the body because it discards it. So since it discards it, we remove the B, right? We remove the lambda B. We remove the second because there is no, the second cannot go inside of the body because there is no space. Sorry. So we are left with FST. So that's these are our evaluation steps. And this is very helpful to practice. Because in some sense, and when I look at Nick's code, I was like looking some of the stuff and it's so similar to this. I mean, I haven't seen this actually recommended. Like, let's say, yeah, there was this function that I was system and finicil system. So there's this function that recurses through directories from his. Where is it? Default.next. I think it's no. Like, check this out. Wait a second. Is it here? No, here's importing here. You see, I haven't seen this in a while. New modules. I think it's here. Default.next. Maybe it's here. Yeah, like look at this. Recursively constructs an attribute set of a given folder. Yeah, right. I mean, this might seem now, you know, hard to understand, but just look at this function. Get dir, right? So get some directory is what? It's like when we name things in the REPL to give them a name for some function definition. And look a lambda head and look a function, right? Almost like lambda A, lambda B, only here we have just one lambda head. So this is the function head map attributes. Okay, it's not important actually what this does. I get it maps attributes or something, but I'm just looking at it more like map attributes is a function. And now look, this is in so look at, so we have like this. Yeah, so we have a lambda head. This would be like an F. This is an A, and this is a B. So we have an FAB here actually. So we have a certain function equals what? Equals lambda, well, this is lambda something, has a head and has a 3 arguments within the function body. So when you start to look at so it's just, I mean, before when I would look at this, you know, you immediately start to zoom in. Okay, what does map address means? What does this mean? What does this mean? But then, you know, like you don't have this zoom out outline of how the code actually, you know, works. And I've noticed that practicing, you know, how lambdas work. So how this kind of evaluation works, this substitution, can really like indirectly help how these guys work. I haven't seen this recommended in the Nix documentation, but I think it would be helpful if there was like a little tutorial on how functional application actually works. Like when you look at functions like this. So also look at this. So this is a head and there is a function here, so an argument here. And then within this argument, we have another head. We have 2 heads here now. We have a file and a type. So if type, and then I have an if statement. And the if statements actually we're going to be doing now soon in this Lambda book. So if type is directory, then get dir, this first thing, over dir and file, else type, and then built-ins read dir. So also now I'm not sure how the evaluation steps go. It would be interesting, instead of parsing everything in the head, it would be interesting to actually see the, I don't know if this would be actually possible. I don't know, this is nice. Wait, maybe chat can do actually that. Chat, I've used chat for the evaluation steps in Lambda calculus, and that kind of works nice. Can you show me the evaluation steps? Like in Lambda calculus? So do not explain what the code itself does, but show me the eval steps, just like in Lambda calculus, beta reductions and such, and alpha conversions and such. But with this function, maybe, yeah, let's see. I'll represent it as a sequence of evaluations akin to Lambda calculus reductions. Right, so getDir is recursively constructing an attribute set. I'll start from definition and progress step by step with a hypothetical input. So it needs an input, right? File 1, regular, folder 1, directory. Oh, it needs some kind of an input. Right, we do need an input. Just like we did in Lambda calculus. Just like with this here, FST, SND, that was the input, right? And these were the, so this is the function definition itself without the input. That's correct. So assume dir1 is example, and built-ins read dir example produces. Right. Okay, so dir is example, and it produces Oh, read dir. So I don't even know what the built-in's read dir does. It reads, I guess it reads the directory. It reads the directory and creates an attribute set with the keys and values, right? And the keys are file and the value is regular. Here key is folder and value is directory. Although in this sense, these are like types. So apply the input dir to get dir. So get dir example expands to map address, right? File type, if type directory, then get dir example file. Oh, he's substituting here again. Else type built-in's read dir example. Evaluate built-in's read dir example. Replace built-in's read dir example with its value. Map address file type, if type directory, then get dir. File 1, oh, it's substitute. This is interesting. Folder 1 directory. Expand map address for each key value pair in the attribute set. Oh, so now when we have the attribute set, apply the function file type. Key file 1 value regular, key folder 1 value directory. So these are intermediate results. File 1, let file equals file 1, type regular, and if type directory, then get dir example file, else type. Folder 1, let file folder 1, type directory, and yeah, you see, I'll have to read this through. Substitute value. I'll have to study this slow. It's just, I don't know. Like such a simple Nix function, well, the point is to start being creative with Nix and to really get to the gist of it, right? To see how the code moves and sort of, in some sense, to learn some way of improvising with Nix code. Because it's functional, it's almost like a assembly kind of a functional, it's like an assembly language because everything is a function. Everything is a function, so you can create functions from other functions. And that's kind of very nice in some of these examples that you can see. So sure, you can write your, your Nix sauce. Now I'm going into tangent. Sure, you can write your Nix sauce, but after a while, you see there is this type of, movement. Substitute values for folder 1. Wait, how long? 37 minutes. Is this thing working? Maybe it's not even working. Am I streaming? Oh wow. My camera is completely off. This is, wow. Why does this happen? I guess I have to restart it. Yeah, I have to restart it. Look at this video capture. Let's remove it. This is weird. This is already Pipewire video capture. Yeah, now it works. Yeah. Wait, 640. Yeah, right. Okay, I'm back. Yeah, 2 viewers. So what was I doing? Yeah, right. I've lost my train of thought. Yeah, because of yeah, the Nix. Where is it? Here. Right, I was looking. ChatGPT is really great for evaluation steps. If you really explain well what the function is, what it does, it can show well the intermediate Lambda steps, which is kind of cool. And look at this, collects all files of a directory as a list of strings of paths. Files equal dir collect. So we can see that in Finicel is quite virtuosic, or in the sense he can create. So this is not the level of copy pasting or applying stuff, but this is like yeah, he's like playing nicks. Files dir collect string map address recursive path type concat string sub path. Basically, this is functional programming, but there are no types. The filters out directories that don't end with nix or are this file. Also makes strings absolute. Valid files, dir map file. Yeah, I think I'll have to make a whole stream just on this subject. All right. So select first. So nix REPL. Oh, we just lost it. Okay, select first. So yeah, it works. Make pair. So yeah, that's what we did last time. And then we did the cond. I think I'll stop soon. This was I think I have to start slow. I haven't streamed in a while and this is already a lot. So we did the cond, but the weird part is, and that was like a big stepping stone. Like select first, select second, make pair, identity, apply, self-apply. They're in some sense at a already one level of abstraction. But the cond was interesting, and the true and false, the Boolean operators, because they introduced something else, like select first is true, right? And that comes weird. Select, like, let's do true. No, let's do true. No, let's do do I have true here? I have true. Okay, true select first. Maybe I'll put just true like this. True is, do I have this? No, I don't have. Okay, true is select first. And false is select second. And the weird part is that the make pair is basically cond. Make pair is cond. Yeah. Now, this is kind of tricky because it's the same abstraction, but the name is changed. So it almost has a new context. It has a new context. It's a different context now. It's not anymore select first. It's true. Now it might think, you know, it's what's confusing at first. So if I say, like, because you might say what's true? Well, true is select first. And false is, and that's what was confusing also. The video from David Beasley from PythonCon, from Python, where is it? He did this, if you write on YouTube, Lambda, Calculus, David Beasley, Python, he has this really long 3-4 hours long course on Lambda Calculus, and he introduces this true and false already at the beginning, which I find even a little bit too fast. But it was interesting, and he was explaining nice how that is so confusing. So a higher level functional notation. Here is, it says higher level functional notation. So we will use the pair function. So also the thing with functional programming, you always reuse what you know, which is very comforting, because everything what you learn, it will not be wasted, which is a very nice feeling. It's almost like you're always expanding your understanding. First of all, we will use the pair functions from chapter 1 to represent conditional expressions with truth values, true and false. We will then use these to develop Boolean operators like not, and or. And I had no idea how to develop them, because again, it was about being playful with these heads and bodies, with heads and bodies. Next, we will use the pair functions to represent natural numbers. Okay, he's like almost every, yeah, okay. Next, we'll use the pair functions to represent natural numbers in terms of the value 0 and the successor function. And finally, we will introduce notations for simplifying function definitions and lambda expressions, and for an if-then-else form of conditional expression. For the moment, we will be looking at untyped representations of truth values and functions. We will develop typed representations in chapter 5. Interesting. Now, did someone write back on the Nix documentation? Not yet. Someone's seen it. Joe Pye. Oh, seen by 6 people. All right. Well, maybe I'm sure Fritz will write something. Yeah, okay. Okay, I'll stop this. So truth values in conditional expressions. So Boolean logic is based on the truth values true and false with logical operations not, and, or, and so on. We're going to represent true by select first and false by select second and use a version of make pair to build logical operations. Okay, I'm going to do this next time. I had enough for today. I haven't streamed in a while and this was very nice and I have some more stuff to do. So I'm going to stop here and I will be more consistent now after the holidays. And yeah, interesting. Well, it's good to be back. Bye-bye.